On behalf of Struct Soft Centre, once again, I would like to welcome you all guys in this new training program under the title of Complete Substructure and Floor Slab Design using CSI Safe, Excel and Manual. So we basically have decided or divided this complete training program in the three levels as beginner level, intermediate level and advanced level. So we were planned to cover all the manual calculations and its understanding in the first part, or we can say in the beginner level, that we have given as a self learning portion. So hope that you all have completed the beginner level on your own. So whatever your doubts and questions, you can ask me personally. I'll try to answer to all that questions. And now from today's we have planned to start our intermediate level. And firstly, I would like to describe what the things we were planned to cover in this intermediate level. So we are going to start this intermediate level with a general discussion of what is the foundation, what is the soil, their properties, their responsibilities. So some conceptual understandings will be there, that is actually very essential to go for the real projects. Unless and until you are not having the clarity about your foundation, about its responsibilities, about the soil, its responsibilities, its importance in the overall structural response, so you will not able to do the design effectively, you cannot perform your job effectively. So very first thing is need to understand the concepts. So we were planned to cover the concepts, okay, in this intermediate level. Thereafter there will be the stage of the validation. As you have learned the manual calculation of all different types of the foundations, now all that different types of the manual calculation of the foundations, we are going to check it with our proposed software as the CSI safe. So how for each individual types of the foundation you can do the modeling analysis and design in the CSI safe software. So that is the second part of your intermediate level. And in this intermediate level only we are going to talk about the sample project. And in that sample project we are going to cover all about the CSI safe software. And the objective of that sample project will make you all guys be ready for the real example project that we are going to take in the advanced level. So three major sections will be there in this intermediate level. Firstly is the understanding of the concepts about this foundation, soil, superstructure, substructure, methods of explorations, detailed introduction about your soil investigation report, how to read the soil investigation report, how to take out important details from the soil investigation report. Everything we are going to talk first. Thereafter, we are going to talk about the sample project. Okay, in that sample project, you will be confident to deal with the CSI safe software. And thirdly, we are going to talk about the validation of the CSI safe software. So this is the major contents or headlines of your intermediate level. And thereafter we are going to discuss about our advanced level. And in advanced level, as per the plan, we are going to take a few of the real example projects where plan to cover all the different types of the foundation. So now you all are ready to go to get start with intermediate level. Okay. Okay, so many of the things might be in your knowledge that I'm going to discuss right now. Okay, and some of the new things you are going to learn by today. So let's start without wasting time. Hope my screen is clear to all of you. Now, as you all know that any kind of the structure, if you are going to take, so it is having the two parts. One is your superstructure, another one is your substructure. That's very simple. The part which is going to present above the ground level, above the natural ground level, that is we are going to call it as a superstructure, and the part that you are going to put below the ground level, that is termed as a substructure, right? So basically, the load transfer mechanism is what? From the superstructure, if suppose you are going to talk about the building, okay, it's not only the building is the superstructure. If you are going to talk about the bridges, so bridge is also having the one superstructure, one is substructure. If you are going to talk about any I can say the steel structure, any iconic steel structure, if you are going to take into consideration, so it is having the superstructure, it is having the substructure. So every structure will have the two portion. One portion is above the ground, one portion is below the ground. The portion which is above the ground we are going to call it as superstructure, and the portion which is below the ground is your substructure. But you will say that, sir, it's a very common thing. Okay, we all know, we all are knowing these things. So yeah, you are correct, but actually we are well our concept is well clear in respect of our superstructure. The part which is going to be present above the ground, we are going to call it as superstructure. But there are some myth, there are some lack of understanding about the substructure that I am trying to resolve, or we are trying to like break that myth in today's session in respect of the substructure. So superstructure will include your beam, column, slab, all that's are there, and there is a substructure below the ground level. We are considering our foundation is the substructure. Okay, fine, no issue. Now, what is the load transfer mechanism? So whatever the load you are going to put over the slab element or the floor element, that is going to be transferred to your supporting beam element. That is going to be transferred to the supporting beam element, and now the beam will transfer that load to the supporting column, then through that column, then again slab, then beam, then column, like that the load transfer is going to be done for the superstructure up to the level of the ground. And now from this ground again it is transferred through this column, and this column will going to transfer the load to the your foundation. This is we are going to call it as our foundation, which is actually responsible to take the load from the superstructure. But my dear friend, try to understand, this foundation is not actually the responsible for carrying the load. It is actually responsible for transferring the load which is coming from the superstructure, and your foundation will ultimately transferring the load which is coming from the superstructure to the subsoil, over which the structure over which your foundation is going to rest. So overall, if you are going to see, your entire structure is going to not supported by your foundation. Your entire structure is actually going to be supported by your subsoil. But in our understanding is what, when we are talking about the substructure we are considering about your foundation. No, your foundation, your concrete plate that you are going to put here, concrete slab that you are going to put here, it is ultimately going to be supported by your subsoil. So your foundation and your subsoil will combinedly termed as the substructure, the structure which is below the ground. Okay, so whatever the structure you are going to talk about, whether it is a bridge structure, whether it is a building structure, whether any other type of this structure, if you are going to talk about, it is having the two levels or two parts, superstructure and substructure. And in substructure, your foundation is not only the substructure, but also it is including the subsoil over which your entire structure is going to rest. Are you getting? So it is actually your foundation slab is actually the platform which is giving the your foundation is just a platform which is giving the which is giving to the superstructure, and the load which is going to be carried by your foundation is going to be transferred to the subsoil. So ultimately your subsoil should be strong enough for whatever the load you are going to apply over that. Ultimately is what, your foundation should not be enough only, your subsoil will also have the enough strength to carry the load that you are going to put over the soil through the foundation for a superstructure. So this soil mass should be stiff enough, your soil mass should be firm enough to carry the load that is coming from the superstructure. But my dear friend, it is not that much easy as we are discussing. It is not that much easy as we are discussing. Why? It is because there are a lot of challenges are associated while finding out the properties of the soil. Actually, if you are going to put your entire structure over the soil, so you should have the knowledge about the properties of your soil. What is the shear strength of the capacity, shear capacity of your soil, what is the aerial pressure load carrying capacity of your soil. That is very important to know. Unless and until you are not able, you are not knowing the capacity of the soil, you are not knowing the strength of the soil over which you are going to put your structure, so definitely there is a possibility of the complete collapse and failure of the structure if your soil is not capable of carrying the load that you are going to put over. So that's why it is important to investigate a soil, investigate your proposed land over which you are planning to put your structure. Getting? But again I'm repeating, it is not that much easy task to do the investigation for the soil mass. Why? It is because actually in a modern era, in a modern era, what is that there are a lot of uh, advancements are there in respect of the architectural consideration. If you are going to talk about the superstructure, so lot of iconics, lot of complications are there. Okay, lot of new inventions are there, I can say. Okay, lot of changes are there in respect of architectural consideration, in respect of superstructure construction, superstructure design, superstructure architectural consideration. So lot of advancements are there, and that is possible to achieve. That is what possible to achieve if architect has given this kind of structures, this kind of projects. So that is possible to achieve. Why? It is because for the superstructure what materials will be there, there may be the material either of concrete, there will be the material of steel. What else will be there? RCC will be there, steel will be there, steel elements will be there. So that all are going to be that all are actually what, natural elements or man-made materials? Tell me, that will be what? Either man-made materials it will be, or either it will be the natural elements. What it will be? Tell me. It will be man-made. So for the case of the superstructure, whatever the challenges are there, that is possible to tackle. Whatever the proposed plan is there, that is possible to execute in respect of construction, in respect of the strength, in respect of everything, in respect of the element geometry, that all are possible to achieve. And especially the strength is possible to achieve. Like if suppose you want to have the very high strength steel material, so that is possible to get, that you are going to do in laboratory, in factory, and as per the testing, as per the inspection, you can get a required strength of the steel. If suppose you would like to high strength of the concrete element, concrete material, or concrete grades, that is also possible to get. So up to a certain extent, whatever the challenges are coming, whatever the new advancements are coming in respect of the superstructure, that is possible to achieve, that is possible to get, that is possible to execute. But when you come to talk about the substructure, and as I told you, substructure is not only your foundation. Okay, break this myth. Substructure is actually the combination of your foundation and subsoil. And in this two, the main part is your subsoil. In this two also, your foundation is not that much important. Your subsoil is the mainly the concern. If your soil is failing to bear the load, your entire structure is going to collapse. And my dear friend, the main thing is that the subsoil is actually the natural element. The subsoil is your natural element, that is not the man-made element. Okay, remember this point. And that there is a limited scope, there is what, note this point, there is a very limited scope to get the required strength of your subsoil. You don't have like, you don't have different options, or you don't have the option to strengthen the soil in respect of its cost consideration, in respect of its surety, even by after strengthening the soil, whether it will perform as per our expectation or not. So there is a very limited scope to get the desired strength of the soil. Okay, for the desired architectural consideration, for the desired new advancement. Okay, for the desired new uh, 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 design concepts, for the design new architectural consideration and requirement. So for that you will not able to get a required strength of the soil. That is what the limitation with your soil mass. So lot of, because it is what, it is the man, it is not the man-made material, it is what, it is actually your natural elements. And with this natural element we have the limited scope of manipulation, limited scope of strengthening the soil, limited scope of increasing the strength of the soil for the purpose of carrying the imposed load. Is that all clear? Yes or no? Okay, so the thing is what, superstructure, substructure. In substructure we are having the foundation, in substructure we are having the your subsoil. And in comparison of your foundation and subsoil, the major role where is going to be played by your soil. And soil is not a man-made material, is a natural material. And with this natural material we have the lot of challenges, because we don't have the option to get the required strength. Whatever the strength is available on site, we have to play with that, we have to go with that. Okay, we have to go with that. If you are planning to increase it, then it is like a very limited scope. If you would, if you want to you cannot do any change. Yeah, when you are talking about the superstructure, okay, suppose column is failing, suppose beam is failing, suppose any element is failing, so what you will do, you will increase the reinforcement, you will increase the size of the column, you will increase the grade of steel, you will increase the grade of concrete. But my dear friend, when you are not getting the required strength, okay, for the soil, then there's no scope. That is what the first problem, as your natural soil is a natural element. Now second problem, actually this is the first thing. Second thing, knowing of knowing of property of existing soil mass, knowing of property of existing soil mass, that is the another challenging job, challenge in the field of this is structural design, or in the field of geotechnical engineering, or in the field of soil investigation. Okay, it is another challenge. There are a lot of challenges associated for doing the examination of the existing land, for knowing the properties of the soil, for knowing the strength of the soil, for knowing the capacity of the soil. What are those challenges? Let's try to understand. Actually, soil exhibits complex behavior and challenges in engineering as discussed below. What are the points? Try to understand. Natural soils like a linear stress strain relationship and exhibits a diverse property. What does it mean? Try to understand. Actually, in reality, in reality, your soil mass will not follows the Hooke's law. In reality, your soil mass is not going to follow your Hooke's law. What is the Hooke's law? That whatever the load you are going to apply over that soil mass, if you are especially going to talk about the soil, so if you are going to apply the load over the soil mass, so in respect of application of the loading, or in respect of increase in the load intensity, accordingly your the stresses or the resultant or the displacement or the settlement in the soil mass should be done accordingly. Whatever the load you are going to apply, accordingly the displacement or settlement in the soil mass should happen. But in reality, it is not the case. Actually, those like scientists, if you are going to talk about, or if you are going to talk about the geotechnical engineers, those who are going to do the soil investigation, they are what, assuming that the soil is a linear, soil exhibits the linear stress strain relationship. It is the assumption is needed to make to get the solution. But in reality, your soil is not a linear stress, is not having the linear stress strain relationship. Means what, in simple, whatever the load you are going to apply, in the proportionality the displacement should occur in the soil mass. If the soil is there and I'm going to put the load over that, so if I'm going to increase the load, settlement will increase. If I'm going to further increase the load, settlement will increase. If I'm further going to increase the load, settlement will increase. Like suppose you are going to talk about the foundation. Suppose this is my foundation, this is my column. So through the column the load is coming to this foundation, and foundation is going to impose the load to the subsoil. So in the soil there should be a settlement continuously in respect of the increase in the load. So if this kind of behavior will be there, it is called as what, linear relationship in the load and the displacement or settlement. And that we are going to call it as what, we are going to call this as it is actually going to follow the Hooke's law. But in reality your soil is not having the linear stress strain relationship, and it is having the it exhibits a diverse property. Means there will be no linear displacement, there may be sudden displacement, there may be like even by increasing the load there will be no displacement. So linearity will not be there, randomness in the response of the soil mass will be there. First thing, this is the one challenge. So what we are doing, we are making it as what, assumption, because if you are going to follow this, अगर आपने इसको क्या कह दिया, if suppose you are going to consider this in reality, so your research or your examination will become very very complicated. अगर आपने इसको रियलिटी में कंसिडर किया तो फिर आपका जो स्टडी है दैट इज गोइंग टू बिकम वेरी चैलेंजिंग and very complicated. That's why even the scientists, while they are going to do their study, they are considering that soil is having the linear stress strain relationship. Understood? Yes or no? First point. Okay, now the second challenge is what, soil is non-homogeneous, anisotropic, and varies by the location, its property, its strength. Okay, and it's a means everything where is going to be varying in respect of its location. I will explain it. Try to understand. Actually, soil is non-homogeneous, anisotropic. Means the stresses if you are going to apply over the soil, it means like material will have the every soil mass is made up of the different particles, and each particle will have the unique properties. Unique property, soil mass is made up of different particles. The layers layers will be of different particles. So every particle will have its own property. It's having its own stiffness, it is having its own shear capacity, it's having own bearing capacity, every particle. So how we can say that soil is the homogeneous? Means a one area, one by one area of the soil, if suppose I am going to consider, so you cannot ensure that the property of the soil at every point will be same. No, because soil is not homogeneous, is anisotropic, and it is varying by the location. As I told you, if you are going to consider a very big area that is needed to investigate, and you are going to build the structure, you want to build the structure over this land which is having very large area. So will you ensure that if you are going to do the testing, or if you are going to do the investigation at this point, if you are going to do the take a pit, okay, and you are going to do the test for finding out the bearing capacity of the soil, for testing for the settlement, for the shear capacity, for whatever you are going to do, either you are going to do the on-site testing or laboratory testing for this portion, for this, and for this, and for this, can you ensure that the property will exactly match for all these 4 points? Will exactly match? No, that is what it is not possible to get the same property, same strength for all these 4 points. So in respect of the location, the properties of the soil is going to be changing. The properties are going to be changing. So at every point, the properties of the soil is going to be changing. So it is again the one challenge in reality, to what number of points you are going to do the investigation: 1 2 3 4 5 6 10 20 30 50. Then moreover of that, if suppose very large area is there, so n number of points you need to investigate. At every 1 meter interval you need to perform. So that is not practically possible. Are you getting my point? If a very large area, if suppose I am going to give you, so try to understand to what number of points you are going to do the investigation, either 1 5 10 20. But as I told you, even if you are going to do the testing at this point, nearly at 20 meter 30 meter, again if you are going to do the testing, so there may chance that you will get the different properties, the capacity may going to be changed. So that is what the property and strength of the soil mass is going to be varying over the area. It is going to be varying by the location. So this is what the second challenge that we need to consider in our investigation. We need to take some factor of safety against this condition. आपको इसका फैक्टर ऑफ सेफ्टी आपको लेना पड़ेगा. Your soil is what actually non-linear, and in your analysis you are going to consider, in your testing, in your investigation you are going to consider a linear. तो जो रियलिटी है आप उसको इग्नोर कर रहे हो टू मेक योर स्टडी एज इजी. सो यू हैव टू टेक द फैक्टर ऑफ सेफ्टी. इसके लिए आपको कुछ सेफ्टी कंसिडर करना पड़ेगा, बिकॉज रियलिटी यू आर गोइंग टू स्किप. And if suppose you are going to consider the reality, so it is very difficult to do the investigation, it is very difficult to do the study. आपको स्टडी करना डिफिकल्ट हो जाएगा. फर्स्ट. सेकंड, सॉइल इज होमोजेनस. अगेन योर सॉइल इज नॉट होमोजेनस एंड इट इज प्रॉपर्टीज आर गोइंग टू बी वेरिंग बाय द लोकेशन. अब इसको भी आप इग्नोर कर रहे हो, देन यू हैव टू टेक द सेफ्टी फैक्टर ऑफ सेफ्टी in your final design results. Now soil behavior is influenced by the environmental factor, pressure changes and time. Actually again what soil capacity, soil strength is what surface subsurface location. As of now we have seen for a very large area the property at this point, property at this point and property at this point will not match. आपके तीनों पॉइंट्स पर प्रॉपर्टी मैच नहीं होने वाला है. Likewise we are going to see over the area. Now if you are going to see for the same land, for the same land, if I am asking, suppose this is your ground level. Now if I am going to do the testing at a depth of 1.5 meter, then I am going to perform that at that same location, if I am going to do the testing at 3 meter, now again I am going to do the testing at 5 meter, now again I am going to do the testing at a 10 meter. Tell me the properties at every depth, at each different depth will be same, at its plasticity, at its bearing capacity, at its settlement, okay, at its moisture content, at its water level. Okay, will it be same? No, it is not going to be same. It is what going to be varying. So in reality, what to a what depth you can do the exploration? Reality में आप कितनी डेप्थ तक परफॉर्म करेंगे? If I'm asking to do the testing at every meter of interval, at every 0.5 meter of interval, it will be possible to do, and to a depth of 100 meter it will be possible to do. If you would like to have the actual response, तो आपको इतना करना पड़ेगा, you need to do this, but in reality, in practical consideration, it is not possible. It is not possible. But in reality, actually the thing is that we should consider this, but practically it is not possible. Then again you have to take the some factor of safety against your lackness to consider the reality. आप रियलिटी को कहीं ना कहीं इग्नोर कर रहे हो, तो उसके लिए आपको क्या लेना पड़ेगा? यस और नो? यस, टेल मी व्हाट reality. We are going to compromise with the reality, we are going to compromise with the actual thing. In that situation, what we need to do? Yes, we need to take a factor of safety, right? So this is the second what number, third challenge associated with the soil exploration. Due to its subsurface location, so, okay, environmental factor. What the environmental factor? Try to understand. Like the soil in rainy season, okay, the soil property may going to be changed, soil nature is going to be changed. In a summer season it is going to be changed. In the winter season it is going to be changed. So in every season, in every environment condition, okay, the properties are going to be changed over the time, it is going to be changed. And due to its subsurface location, soil behavior is inferred from small random and sample. Okay, due to its subsurface location, soil behavior is inferred from small random samples. Okay, random samples. Okay, try to understand. Actually, okay, take this fifth point also together. Soil samples are sensitive to disturbance potential affecting lab predictions versus in situ behavior. See, actually the thing is what, if suppose you are going to consider a big area again, and you are going to take the sample from a one point, and then you are going to do the investigation at this point. So two options you are having actually. One option is what, either you can do the exploration on site, or you can do the exploration in laboratory. Two options you are having. One option is to do the exploration either on site, there are different method we will see. Okay, so on site you can do the testing and you will come to a conclusion what is the property of the soil. And second option is that you can take the sample from the site, and you can take that sample in the laboratory, and in laboratory you can perform the testings, and through that testing you will come to know the property of the soil. So either you can perform on site, or either you can perform on laboratory. But my dear friend, can you ensure that the testing we are going to be done on laboratory, in laboratory and on site will be same? Yes or no? It will be same? No, it is not going to be same. It is going to be varying. ये क्या हो रहा है, रियलिटी में आपका वैरी होगा, बट एक्चुअली सॉइल इज सेम. Reality is what, soil is one soil is there that I'm going to perform on site, that for the same soil, for the same depth, for the same location, for the same land, I'm going to perform the testing on laboratory and testing on the soil. So testing on the laboratory is testing on site. In reality it should be same, it is actually same, in reality is 100% same. But if I am going to do the testing in laboratory and I'm going to do the testing in on site, then definitely you are going to get the different result. Why it is? Try to understand. If actually your soil mass are very very sensitive to disturbances. Hello. In a situation, see, when I am going to consider at a depth of 2 meter, suppose I am going to dig a pit, okay, and I am going to take a sample from this point which is at a depth of 2 meter from the ground level. Okay, ground level से आपका यहाँ पर फाउंडेशन हम लोगों को पुट करना है, and we are going to do the testing at this level at a depth of 2 meter. So one time I am going to do the testing at this 2 meter depth on site, and second time I am going to take a like what sample from here. I am going to take out the sample, small sample of the soil mass, and that I am going to carry in the laboratory. Okay, so what problem is there? Actually, in the first case, your soil is what in compact form, the stiffness to the soil. This is the soil, okay, over which we are going to perform. So it is having the stiffness support from the surrounding. It is in compact form. So at this point, it is showing a little bit more stiffness, more capacity, more bearing capacity. But after while taking out the sample, there may possibility of cracks formation. There may possibility of the cracks formation in the soil mass. There may be disturbances, breaking of the parts of the soil, breaking of the elements of the soil, like particles of the soil, and due to that it is going to lose its actual stiffness, its actual property. First thing that is going to be happen on site, and whatever the moisture content on site is there during the while carrying in the laboratory, it is going to lose, or the moisture content of the soil mass is going to be loosed from its actual site moisture content. And due to that reason, there will be the difference in the laboratory testing result, on site testing results. Are you understand this, agree with this, yes or no? Okay, so here again we need to consider some factor of safety against our lackness, or our by over this reality, over this what reality. Just a minute. So these all are the some challenges in respect of finding out the actual capacity of your soil mass. Okay, and first thing, second thing, the soil is having the limited scope of manipulation. You cannot increase the capacity of the soil on the proposed land. Okay, so foundation engineering combines the soil mechanics with the practical application, often referred to as a geotechnical engineering or geotechnique. It involves using both scientific knowledge and practical skills to solve the challenges like interpreting incomplete or conflicting soil data. So if suppose you would like to do the investigation for the soil, so the person who is going to investigate the soil, he should have the proper experience, proper knowledge to find the to correct the conflicting data of the soil. Because at different location, because for one project, for one site, only one point will not be enough to predict the actual capacity of the soil. So for that reason we need to do the we need to choose the right positioning of the investigation, which point will be good, or will be important to do the investigation. Okay, then what type of the foundation will be suitable in respect of your design, in respect of your capacity of the soil, in respect of existing property of the soil. So these all things actually required very experienced person which is having the good judgment in respect of the solving the complex problems. Okay, so that's why my dear friend, actually, as your soil is basically is what is a natural element, that's why we need to take the higher factor of safety over its ultimate bearing capacity. Like when you are going to see the soil investigation report, okay, so the bearing capacity they have suggested, let's say for an example 250, let's say for an example as 300 kilonewton per meter square, let's say as 200. But in reality, after doing the exploration, after doing their testings or investigation, they are getting the bearing capacity of the soil as 900, they are getting the bearing capacity of the soil as 800, they are getting the bearing capacity of the soil as 700. But in the report they have suggested to consider 250, they 300, 200. Why? They have taken the factor of safety, and as per the recommendation, the factor of safety for the soil mass is needed to consider between 2 to 3. Normally we are considering it as 3. Normally we are considering it as what? 3, because it is the natural element. If you are talking about the concrete, so as we earlier have seen, concrete is what? Man-made material. Man-made material. So it is having the whatever the strength we are predicting, we are expecting, so approximately by 90 to 95% same strength we are achieving on site, we are achieving on site. So that's why the factor of safety is taken as what? 1.5. What does mean the factor of safety? Actually, what is the capacity of the material to carry the load? Suppose I'm going talking about the concrete. Just for example, your concrete is what? In reality, in actual, concrete is having the capacity to carry the load of 100 kilonewton per meter square area. So I'm not going to consider this it as 100. What I will consider 100 divided by 1.5. So whatever the value is coming while doing the calculation and design, I will consider that strength only. 100 divided by 1.5. So we are going to reduce it. Likewise, for the steel, now actually concrete is going to be what? Prepared on site, going to be casted on site. That's why we are taking here what? More chances. So a little bit in comparison of steel, there's more chances of not getting as per the expectation. That's why we are taking partial safety factor as 1.5. But when you are going to talk about the steel, so steel is what? Going to made up of made in or built in your factory. It is not going to build on site. It is coming from the factory. So with the proper inspection, with the proper testing, with the machinery, it is going to be done. If you are going to talk about the concrete, so concrete, the manpower is going to work to make your concrete. For a small scale, if you are going to talk about okay, in a very big project, yeah, machinery is going to work there. But if you are going to talk about the structure that is not that much for that not much machinery is going to be implemented to execute the work. There's what? Manpower is going to work. So there's what? Every time we will not get same promotion, proper mixing of the concrete, proper placing of the concrete, proper vibration of the concrete. So obviously the expected strength we will not get. That's why we are taking the factor of safety more. But when you come talk about steel, so steel is what? Coming from the factory, so there is what? Less partial safety factors will be enough, because there is a less chance of reducing the strength. Now when you come to talk about the soil, as we have discussed the many points, due to that reason it is recommended to take the factor of safety as what? 3, or we can say 2 to 3. Is that all clear? So whatever the ultimate load we are getting, ultimate capacity we are getting over that ultimate capacity, the factor of safety has suggested to consider as what? 3. So in your soil investigation report, you are getting whatever the bearing capacity of the soil you are getting, actually that will not be the exact one which is the geotechnical engineer actually getting on site. It is giving after applying the factor of safety. Actually remember this point. This point will be important when we will come to the design stage, when we will come to decide the size of the foundation at the time of the design. I will again take this point. Is that all clear? Okay, now good. So partial safety factor is now over. So my dear friend, now next point is the needed to discuss about the type of the foundations. What are the different types of the foundations? Okay, so basically the foundations are going to be divided into two types mainly in major category as shallow foundation. Another one is your deep foundation. Very simple. Okay, if the depth of the foundation is more than that of the your width of the footing, at that time we are going to consider the deep foundation. And when your depth of the foundation is less than the width of the foundation, at that time we are going to call it as shallow foundation. Okay, so two types of the foundations are there. One is your shallow foundation, another one is your deep foundation. Right now, actually in shallow foundation there are different types. Okay, what are those types of the foundations in shallow foundation? Shallow foundation, as the simple pad footing is there, stepped footing is there, sloped footing is there. Okay, combined foundation is there, stiff foundation is there, strap foundation is there, and mat or we can say the raft foundation is there. So all these types of foundations are actually the shallow foundations. Means the foundations are going to be present close to your ground level. The foundation which is going to be present close to your ground level, that we are going to call it as what? Shallow foundation. In simple, यहाँ पर अगर आप देखेंगे, so आपका जो foundation it is close to your ground level, that's why what we are calling it to shallow foundation. Now why it is going to be provided close to the surface, close to the ground level? Why it is? Because as just now we have discussed that we are going to put our entire structure over the soil. So if you are getting the desired property, desired strength, desired stiffness, okay, desired load carrying capacity of the soil or desired layer of the soil near the ground surface, then what's the problem? I can put my foundation there. अगर आपको अपना desired capacity near the ground surface, if suppose you are getting, so that's a good thing. That's a what good thing. So that what I will put my foundation there and taking my superstructure load to that particular foundation. And as the soil is having this stiff enough, having the strength enough to carry the load, so what's the problem? And if that situation is there where you are getting desired strength, desired capacity of the soil near the ground surface, that's foundation is called as what? Shallow foundation. Obviously you are going to do the investigation, and after the investigation you are getting the capacity as near the ground as enough required for your project, for your load, for your structure. So what you will do, you will put your foundation there. So that foundation is called as what? Shallow foundation. So all the types of the foundation where it is actually here it is present, it is a type of the foundation. It is a type of the shallow foundation. Now as you may raise a question, sir, as it is the shallow foundation, so why these different types of the foundations are there? Actually one foundation should be there. So due to different condition, due to different situations in due to different situation, and what that situation? Actually the load. Actually what? The load and response in your soil mass. Again, I am repeating, due to the load intensity, due to the load intensity and the property on this the property of the soil on the proposed land. Okay, near the ground level, it is having required strength, enough required strength, adequate strength is there, no doubt. Shallow foundation will be there, but there are some situations are going to arise. In that situation, or to comply with that situation, we need to provide different types of the foundation. For an example, if suppose everything is normal, if suppose everything is normal, means the bearing capacity of the soil near the ground surface is adequate, plus whatever the load is coming, whatever the anticipated load is coming through the column, through the column is also what, adequate. So when everything is adequate, simple pad footing will be enough. क्या होगा, simple pad, one column is there which is carrying the some adequate load, and adequate capacity is available near the ground level, so I will provide the simple pad foundation. But my dear friend, if if in a situation when you are having your bearing capacity of the soil near the ground, near the ground is adequate, but the load coming from the superstructure or through the column is very very high, is what, very high. So in that situation, pad footing is okay, but the demand of the depth, okay, is very large. Demand of the depth is what, very large. So what is the limit when you will say that the depth of the foundation is large and not good for simple pad foundation? I will discuss that. And in what condition this depth demand will be more, that I will discuss later. So in that situation, we are going to suggest stepped footing. जब आपका लोड ज़्यादा होता है और डेप्थ रिक्वायरमेंट जब ज़्यादा होता है, in that situation, to save the concrete, to save the cost, to make it economical, we are having two options. Either we can go with the stepped footing, or either we can go with the sloped footing. So I will discuss on these 2 points in detail later on. We will come to talk about the stepped and sloped footing for doing the project or for doing the calculation. Okay, so I'm going to stop the discussion here for this. So these two things. Now third thing, in which situation the combined foundation will be required. Actually, suppose the load we are going to be carried by one column is adequate, the load coming from the another column is what, adequate, but the capacity near the ground surface is also adequate. It is also what, adequate, but unfortunately, when you are going to decide the size of the footing, okay, this is my one column, okay, the size it is coming like this, and for the another column, the size of the footing demand is what, like this. So they are actually what, going to overlap by some distance. Okay, it is what, actually going to overlap. Actually load is what, okay, bearing capacity is also what, okay, but here unfortunately what is going to be happen, the areas of the footing which is actually required to carry the load which is coming from the column is going to overlap. So in this situation, we need to combine the foundation. We need to combine that two areas to avoid that merging, and we are having one footing which is going to carry the two, or it may be more number of columns to carry that load by one foundation. So we are going to call it as combined foundation. Now thirdly, if suppose the wall is there, load bearing structures you are going to consider, so wall will be there, and you are going to provide a continuous footing for that. If one column, if number of columns are there in a one row, that also you can call it as steep or steep footing, or wall footing. For wall, if suppose you are going to put the footing, that is going to become wall footing for a long span for the limiting width. So that is called as what, that is called as wall footing. And if number of columns are there, and for that number of column in a row, in a one row, number of columns are there, not two, not three, five, six, seven columns are there in a line. So that going to be converted into a steep footing. One foundation will be there to carry the load coming from all of the columns. And now next term, very very important, for which people are actually more conscious to know the answer. If suppose your column is coming on the property line, if your column is coming on your property line, like suppose I am going to consider this land, this is my proposed land. Okay, here the column is there, here the column, here the column, here the column. So for this there is no problem, I can put my footing like this, I can put my footing like this, I can put my footing like this, because it is in my area, it is in my property. But and is the next block, it is not my property, it is not my property. But the column I am going to proposed here, uh, as per the structural design requirement, I am going to put the one column here. So can I take the footing like this? Can I take the footing like this? Yes or no? No, I cannot put the footing like this. Why? Because this side is not mine, this side is not mine, this area is not mine, that area is not mine. So in that situation, what we need to provide the eccentric footing. We need to provide the eccentric footing. So in that situation, if suppose you are going to design it, so if suppose this is my foundation and I am going to put my column here, so what is going to be happen, this part of the soil will be heavily stressed, this part of the soil is going to become very heavily stressed, while this portion of the soil is what, not stressed that much in comparison of the left part. And due to which unequal pressure distribution will be there, unequal settlement will be there, and lot of challenges will be there. And in that situation, what we are to normalize the load transfer from the one common center point, in order to avoid this eccentricity, we are combining this footing with a adjacent column, with a adjacent column foundation. We are going to combine it with a beam, with a beam, and that type of the foundation is going to be called as what, strap footing. We are going to call it as what, strap footing. So this eccentricity we are going to be controlled by this line element, that is your beam element, and that beam is going to be combined these two footings, right? So we'll talk on this later in detail, I'm just giving the introduction. And now when you are going to put a one footing to carry the load of all the foundation for your proposed area, that is called as mat foundation or raft foundation, where the soil is, where the soil having different properties by the location, and there's a chance of the, there's a chance of the unequal settlement, there's a chance of unequal settlement, that is what mostly formed in clay soil. When you are going to talk about the clay soil, so in that situation, if suppose you are going to put the individual foundation, so this one individual foundation is going to experience the another settlement, this individual foundation is going to experience the another settlement, this individual foundation is going to experience the another settlement. तो अब हर फाउंडेशन अलग अलग सेटलमेंट फाउंडेशन एक्सपीरियंस करेगा, मींस यू आर गोइंग, योर सॉइल इज गोइंग टू बी settled by 5 mm, here it is going to be settled by 20 mm, here it is going to be settled by 15 mm. Okay, unequal equal settlement which leads to the what, instability in your superstructure, and may become a cause of the formation of the cracks in your foundation. Settlement soil में होगा, so there may possibility of formation of the cracks or failure in your foundation, as well as superstructure elements will also experience the cracks formation. ऐसा नहीं है कि आपका सिर्फ फाउंडेशन ही लाइक डैमेज एक्सपीरियंस करेगा, your superstructure will also going to experience the failure in respect of the cracks, in respect of फ्लैक्चरल फेल्यूअर्स, shear failures, वो सारे फेल्यूअर आपके सुपर स्ट्रक्चर में भी फॉर्म होंगे. आर यू गेटिंग माई पॉइंट? सो टू अवॉइड द अनइक्वल सेटलमेंट for the loose and clay soil, okay, it is having enough strength, but it is the type of the clay soil, it is the type of the clay soil. In that situation, or loose soil, in that situation, the experts are recommending, or geotechnical engineers are recommending to consider the raft foundation. Okay, so these are the different types of the foundation and their preference in the different situation and conditions. Overall, it is all are the shallow foundation which is going to put near the ground level or near the ground surface, because we are getting the required adequate strength. But in another case, when your desired strength or desired capacity you are not getting at a desired depth, at a desired depth, if suppose you are not getting the your required strength, in that situation what we need to do, we need to carry that load to a greater depth, unless you are not getting your desired strength layer, desired strength. And that type of foundation is called as what? Deep foundation. That is called as what? Deep foundation. And there's a one most common type is your pile foundation. Actually a lot of other types of the foundations are there, but that is out of our syllabus, and we are limiting to make our discussion for the pile foundation. So इसमें क्या होता है कि आपका deep foundation, we need to transfer that load to a greater depth. Why? Because you are not getting the layer which is enough to carry that load. दो condition है, try to understand. In first case, the load is what? Normal. That is not much more. That is what? Not much more. Like suppose, okay, it is a tall structure I have considered. Suppose only two floor is there, but near the ground, very less capacity is there. Very less capacity is there. So what will happen? वो वी नीड टू ट्रांसफर दैट लोड टू ए ग्रेटर डेप्थ. हमें क्या करना पड़ेगा? ये लोड को ग्रेटर डेप्थ पर लेकर जाना पड़ेगा. आई नीड टू चेक फॉर द डेप्थ ऑफ 5 मीटर. आई नीड टू चेक फॉर द 7 मीटर. I will check for the 9 meter. Now I am getting the required depth, required strength at this level. So what? I will carry that load to this level, and then that is not possible for the simple pad foundation or shallow foundation. That is possible through your deep foundation. That is nothing but your pile foundation. First case, when you are not getting the required and desired capacity. But if I am telling you that there is a design, there is a required strength you are getting, यहाँ पर आपको required strength मिल रहा है, that is what? Good enough for the normal and general condition, for the general case. But still I will look for the deep foundation. I will go for the deep foundation. Why? In a situation when you are going to talk about the tall structure, and obviously your column will carry very high intensity of the load. Actually load is capacity of the soil is adequate. आपका soil adequate है, that is what? Good for the normal condition. But your load is not with normal condition. आपका load normal नहीं है. आपका load very, if your load is very very high, because you are going to talk about the tall structure like 30, 50, 60 floor building you are going to talk about. Okay, you are going to deal with, and that building will carry that building column at its base, that building shear wall at its base carry very high intensity of the, let's say, gravitational load especially. So in that situation I need to put that load to a greater depth. Understood? Yes or no? Okay, right. Now what next thing, try to understand. So hope that's clear to all of you. Next thing, so people are actually asking this question many times, sir, on what basis we have to decide the type of the foundation? So I have given some this explanation to understand, and I have given all that explanation summary in this table. So when you are going to study, you can refer all these things, all the discussion that I have given, that we have done. It is what, here it is summarized. One more important thing you will find here as minimum bearing capacity required. So it is, don't take it much serious. Okay, like people now after looking at this, they will ask, sir, if the bearing capacity is 100, then shallow foundation. No, it is just for the reference it is given. It's all depends on what, your site condition. Here it is what, these minimum bearing capacity values are typically guidelines and can vary based on the specific project requirement. As I told you, the choice of the particular type of the foundation. Wait for a minute. Wait for a minute. Yes, am I audible? Okay. So what we are talking about? Yeah. So I'm telling that this bearing capacity is just for the reference, you can read it out. Okay, and you can understand, like suppose for the pad foundation, like it is the individual pads that support point loads from columns or individual load. Okay, for one column, ideal for isolated columns or a heavy point load. The normally bearing capacity of the soil, if available on site near the ground level, as 200 or higher, so we will go with the simple pad foundation. But it may vary. Why? It is because your type of the foundation is not depends only on one factor. Only on one factor is not dependent. Okay, suppose for the same situation that the load is suppose capacity is what 200 is available, but the load coming from the column is suppose what I can say 20,000. 20,000. So will be the pad foundation will be enough, will be correct? No, we need to go for the deep foundation, because very high intensity of the load is coming. 20,000, 20,000 not a small value in respect of the anticipated load under each of the under one of the column or under one of the shear wall, right? So if one factor will be a parameter, or one thing will be parameter as to decide the type of foundation, then okay. But the type of foundation decision, selection of type of foundation is not depends on one thing, that is your bearing capacity of the soil. No, it is also dependent on your the load, what is the load is coming, right? So it is actually dependent on two things. So that's why we cannot rely only this, but it is just for the judgment and understanding it is given, so you can read it and you can understand it. But again I'm repeating, these minimum bearing capacity values are typical guidelines and can vary based on specific project requirements. Means as per the project, if suppose carrying very large load, very high load, then it will change. Soil characteristic and local building codes, always consult with the geotechnical engineer for a precise calculation recommendation tailored to your project. Yes, so it is just a general reference. If suppose you are going to deal any of your project, then at that time you need to know for your proposed structure. Now very most common question the people are asking, very most common question the people are asking, sir, actually I am living in a small city and there is not a scope of doing the soil investigation, soil exploration. So what I can do for my project? Am I right? You are also having this kind of question? Yes. Okay, so it's a very simple. Actually, even for most of the cities or small cities, this is not possible to do the soil investigation. Actually soil investigation is a little bit costlier. Okay, so it is always not possible to perform the soil investigation for every structure. Actually it should be done. Actually it should be done, but from the point of the facilities, and from the point of the skilled person availability, from the point of the cost consideration, it is not possible to do the soil investigation for every project. So in that situation what to do? In that situation what to do? See here I have given this question for your reference. So in that situation you have to consult with the local expert. You have to reach to the expert design engineer in your in your locality, in your area. You have to consult with them. You have to approach to the geotechnical engineer, geotechnical consultant in your area. Now you will say that, sir, as I'm telling, in my area there is no any consultancy doing this work, and in my area no one is going to perform this soil investigation. So you have to find the person who is actually having the knowledge of this kind of investigation. He has having the experience of working in any of the city, in any of the country. you have to consult with them, you have to uh, you have to consult with the working professionals on site. They will give the judgmental value, they will give the judgmental uh, uh, bearing capacity of the soil for your proposed land. You have to find in past, is there any investigation has been done in your area, near to your area, and that report you can take as a reference. This is the first thing. And second thing, you can follow the standard soil data, general recommendation. Okay, means actually based on the particular type of the soil, different literatures, different books, or different means experts actually have given the standard values of the soil bearing capacity of the soil based on its type of the soil, whether it is a sandy soil, whether it is a clay soil, whether it is a what loose soil, whether it is a rocky soil, whether it is a weathered rock, whether it is a like big rock, okay, composite rock. In that all situation, what bearing capacity of the soil you can expect. In reality, every location will have the different property, but as you are having the problem, there is a shortage to perform the soil investigation for your land. So in that situation, what to do? For a required depth, you need to find out what is the type of the soil, whether it is a clay soil, whether it is sandy soil. Okay, so you need to find that, and based on that, they have recommended the bearing capacity of the soil. If you are getting the gravel, if you are getting the sands, if you are getting the silty sand, so based on that, the bearing capacity of the soil you can consider. You can go for a depth of 1.5 meter. You can do the excavation and find the depth. At this depth to find the soil, then at the another, okay, for the same location further do the exploration. Excavation you can do either on small city or big city. Can you do the excavation or not? Hello, इसका तो प्रॉब्लम नहीं है. यस, एक्सकेवेशन तो कर सकते हो ना. ओके, सो आफ्टर डूइंग द एक्सकेवेशन फॉर द डेप्थ ऑफ 1.5 meter, by the visual inspection, okay, by the visual inspection you will come to know what is the type of the soil. आपको टाइप ऑफ द सॉइल पता चलेगा. ओके, and if you are not having the knowledge to identify the type of the soil, then take the help of the experts. आपको experts help करेंगे. So you need to know the type, then accordingly you can predict the bearing capacity of the soil. Then if you that is not as per your expectation, go for the further depth. Okay, at a depth of 3 meter, I will again going to look at the layer of the soil. Okay, type of the soil. Okay, it is coming out to be what? Sandy soil. On the top, it is suppose silty. I am going for the 3 meter depth, I am getting the sandy soil. Then I am going further depth, deep, I am getting the gravel with fines. And now further I am going for the more depth, as 5 meter I am getting a well graded gravels. No fines are there, no particles are there. And in that situation I can consider that SBC of the soil as 200 to 600. Okay, so visual inspection you can do on site, and based on the type of it may be the cohesive soil, it may be the mixed of this gravel and cohesive soil. There will be what? Rocky soil, weathered rock, means the rock in disintegrated form. Okay, in parts, or there is a solid rock, big rocks may be there. So accordingly the soil capacity you can, bearing capacity of the soil you can consider. Are you getting what I'm trying to explain? Yes or no? This is the most common question the people are asking. Okay, so in on that basis you can decide. Again here I have given the notes, a note, these values are again approximate and should be validated with your local engineer practices or your soil investigation where possible, or do the soil investigation wherever is possible. And you have to consult with a geotechnical engineer. After having the type of the soil, you can consult over a call with any of the geotechnical engineer. He will help you to go for your approximate solution. ठीक है, आपने soil देख लिया कौन सा layer है. Then with that soil you can send that picture to your geotechnical engineer. by looking at that picture they can give the what soil capacity you can consider. Will it be the solution? Yes. So hope that's clear to all of you. So sources for the standard SBC values, I have also given the sources from where I have taken this reference value, approximate value that you can find from here. Is that all clear?